ladies and gentlemen, we would like to start off with our first presentation. We have with us Mr. Alan Cecco, Design Director, Silver Basis Group. He had a rich experience of 30 years in the tooling industry. He is the Design Director of the Silver Basis Group and is located in the headquarters Shenzhen, China. He heads the design team comprising about 150 tool designers. He was earlier with Rockling as the tooling expert. He has also conducted many seminars on tool design, mold flow, and analysis in many universities in China. He's an expert in 2K mold design and 2K product design. This morning, his topic of discussion, ladies and gentlemen, is a look into the 2K mold technology. Please get your hands together, ladies and gentlemen, as Alan joins us on stage.
Thank you. Good morning, ladies and gentlemen. It's a pleasure for me to be here today at this summit. And today I will give you a brief introduction regarding two components mold. Second, please. You switch. So, to produce injection plastic part made by two or more components, there are different mold technologies. We have blade, rotational, horizontal axis, spin rotational, also named cube, which is vertical axis, pick and place or transfer, translation, and overmolding. We start with the blade. So the principle is that the cavity is divided into material area by a blade, a slider. The mold, the part must be designed for blade technology. Here an example. OEM is BMW, the project is F3X, this is a cover cowl. Two material, PPT20 and TPE. You can see on the product, on the bottom, the light blue is the hard material, and the dark blue is the TPE lip, the soft material lip. Here we have the section of the core. So you can see the blade, which is moved by a wedge. And here we have the cylinder that moves this slider. Now we move to rotational horizontal axis. The principle, the mold is divided into cavities for the two different materials and have two same core which they will rotate. Make the injection of the first material, we open the machine, we rotate the core, close the machine, make the injection of the second material. At the same time, we can make the injection of the first material in the outer cavity. The moving half or the core is positioned on a rotational table on the machine or can have a rotational device into the mold. Here the sketch of the mold with the sequence. We have the open mold, the mold close, make the injection of the first material, open the mold, rotate the core 180 degrees, the mold close, injection of the second material. At the same time, we can start to make the injection of the first material in the outer cavity. Open the mold, injection, and we restart from 0.5. We will rotate the core. Advantage. The mold structure is easy compared to blade technology. We have no blade, we have no slider. Two materials can be injected at the same time. Disadvantage, the mold size is bigger compared Blade technology, almost the double. The injection machine is also bigger, and is required a rotational table or a rotational device. The part must be designed for rotational technology or overmolding. Here an example. This is also a BMW project, F45 wheelhouse cover. We have the hard material, and here we have the soft material area. This is 1+1 cavity. Now we move to spin rotation, now also named a cube with vertical axis. The principle, we have two molds with different cavities and same core. The core are positioned on a turntable on the machine. We make the injection of the first material, open the mold, rotate the core, machine close, injection of the second material, and at the same time in the outer cavity, the first one. Here the sketch of the mold. We have the open mold, close the mold, injection of the first material, open the mold, 180-degree rotation of the core. Mold is ready to close the mold, injection of the second material, and injection of the first material in the outer cavity. Open the mold, injection, and we restart. Advantage, the mold structure is easy. It's simple, we have no blade inside. The disadvantage, we have two molds, and we need an extended injection machine with a vertical axis table and the two injection unit. The part must be designed for rotational technology. Here an example. This is for the C519 cow grill. It's also PPT20 NTP. Here you can see the two core. Here we have the two different cavities, and here is the assembly into the machine with the rotational plate in the center. Here a picture of how is the machine, the cube machine. We have the two injection unit for one material for the outer opposite side. Here in the center we have the rotational table. The machine is extended machine compared to a normal injection machine. Here also a detail of the turntable with the vertical axis. Now we move to pick and place, also named transfer. The principle, the mold is divided in two cavities for two different materials. Material one will be moved from one core to the other by a robot. We make the injection of the first material, open the machine. A robot take the part and move to the second core. Machine close. We make the injection of the second material, and at the same time, we can also make the injection of the first material in the first cavity. Here the sketch of the mold. Close the mold. Injection of the first material. Open the mold. Ejection. Transfer by robot to the upper core. Close the mold. Injection of the second material, at the same time the first material in the outer cavity. Open the mold. Ejection, and restart the cycle. Advantage, the mold structure is easy compared to blade technology. No need a rotational table or rotational device into the mold. The disadvantage, the mold size is larger compared to blade technology. Injection machine is bigger. The part must be moved from one cavity to the other by robot. Cycle time is longer. Only simple part can be made. The part must be designed for overmolding technology. Pick and place, so here we have an example. This is a project for Volvo, P313 concealing panel, also PPT20TP. Here we have the two part in hard material, and here we have the lip, soft material lip. Here the core and the cavity. Translation. The principle, the mold is divided into cavities for two different materials. One movable core translates from one cavity to the other. Injection of material 1, machine open. The core translates the position for the second cavity. Machine close, injection of the second material. Here the sketch of the mold, the sequence. Here you can see the cylinder that will move the core, the slider, mold close, injection of material 1, the mold open, core translate, mold close, injection of material 2, mold open, ejection. The core go back, and we restart the cycle. Advantage, no need a rotational table, and we have only one core into the mold. Disadvantage, the size of the mold is bigger compared to plate technology. We have a large core slider moved by a hydraulic cylinder. The injection machine is bigger, cycle time is longer. The part must be designed for overmolding technology. Here an example. OEM is Mopar, project FC556, also cowl top grill, material PPT20 and TPE. Here you can see the big slider, the big core which will move in the upper position. The last one, overmolding. So principle, two molds, one for the first material on one injection machine, and the second mold on another injection machine. The part must be taken from one tool to the other. Here the step, injection material 1, machine open, move the part to the second mold, machine close, injection of the material 2. Here the sketch of the mold, one cavity mold, mold open, mold close, injection of first material, mold open, part injection, transfer to the second mold, close, injection of the second material, open, and ejection. In the meantime, we can restart. Advantage, no need two components machine. All structure is easy compared to blade technology, simple. Disadvantage, we need two molds, cycle time is longer, and we can do only simple parts. The part must be designed for overmolding technology. Now I will show to you a comparison between these 6 different technologies. I take as reference the blade technology, where we have, in this simple case, so one cavity, the mold size we consider 1. We have the blade, the machine size is also 1, turntable, no need, and cycle time is 1. Cavities or molds. So for rotational, we need we need 2 cavities. For spin rotational, we have 1+1 mold. For pick and place, we need 2 cavities. Translation 2. Overmolding, we have Mold size for rotational is almost the double. Spin, we have 2 molds. Pick and place, also the double. Translation, also the double. Overmolding, 1 plus 1. Blade or slider in rotational we don't need. For spin also we don't need. Pick and place also no. In translation we have this big slider. Overmolding no need. Machine size, rotational is almost the double. Spin, we need an extended machine. Pick and place, no need, is almost the double. Translation also. Overmolding, 1 plus 1. Turntable is not required for blade. We need for rotational and for spin. For the other technologies, no. Cycle time, rotational and spin are much more faster. Pick and place depend on the robot and the machine. Translation or overmolding are much more slow. Conclusion. We saw in the global market that blade technology and rotational technology is still the demand, but we saw that now increase the request for mold for spin technology because there are much more and more machines on the market, even if the investment of this machine is pretty big. For India market, we don't know. Let's see what will be happening in the future. Thank you for your attention.
Thank you very much, sir. And may I request Mr. T.S. Gopalakrishnan to please join us on stage to hand over a memento to Mr. Alan Cecco. Ladies and gentlemen, Design Director, Silver Basis Group, Mr. Alan Cecco.